Hi, this is Nick Earl, the CEO of SI. And of course, this is another episode of our IoT Leaders podcast. And in this one, we've gone big. This is a use case in a very large, well-known industrial corporation, Volvo, not the car side, because that's no longer part of Volvo Group, but it's the trucks, it's the construction equipment and the marine engines, amongst other areas. And it is one man's journey over the last 7 years since he joined in 2018 to try and connect every single thing in Volvo. His name is Julien Bertolini. He's based in France and his title is IoT expert. And he talks about what the situation was when he joined, what he did to wrap his arms around the problem and where they are now and all the different technologies and solutions and the use cases that they've got to. Towards the end of the podcast, what you will hear is a very interesting conversation about the power of AI, but not just the power of AI, which I think we all know has huge potential, but how AI is only as good as the data that you feed it. And therefore, you have to feed it in an industrial setting with 140 factories, with assembly lines, where it costs millions if you stop the assembly line. You have to feed it with data from everything. And in his case, everything is hundreds of millions of things. And the more data you can feed it, the bigger benefit you're going to get from AI, because AI in conjunction with the human can make the decision at the edge whether to stop the line or to make a sort of inflow adjustment and let it carry on. And these are huge, important issues for large companies. So this is a very big IoT multi-year journey. It's not even a project, it's a multi-year journey. It's a vision to connect hundreds of millions of physical things inside one company. One final thing before we get started. We did have a few sound issues, and I'm hoping our editing team, who are really good, have managed to close those gaps when we lost sound a little bit during the recording. But if you do hear any interruptions on the final version, just keep listening because the sound comes back pretty quickly. And again, I hope that the editing team are able to close it in such a way where you don't notice it anyway. Okay, so with that, here is my discussion with Julien Bertolini, the IoT expert at Volvo. Enjoy. Julien, welcome to the IoT Leaders podcast. It's good to have you here.
Hello, Nick.
Could we start off? I know you've got a very good story to tell about your journey at IoT in Volvo, which is a very large company, and you just work for part of the company. But before we get into all of that, maybe a little bit of background on yourself and your background and what your role is at Volvo.
Sure. I've been involved in the IoT market since its early days. So starting in 2008, when I began working with machine-to-machine technology. And I have a strong technical background as a solution architect and a full stack developer. So I've developed for mobile, for embedded devices, and also on the cloud. And I've collaborated with various industries to develop the customized IoT solution. And currently, I lead the Volvo Group strategy for deploying technologies in IoT and edge computing.
And remind me, how long have you been at Volvo? Because I think you were in the telecom business before then.
Yeah, 7 years ago.
Okay. And working for Orange before that.
Yeah,
Okay.
absolutely.
And you're in the south of France as we speak. Great. Now, Volvo is a big company. And most people, when they think of Volvo, I guess they think initially of cars, but they also think of trucks. But Volvo do an awful lot of things as well, marine and whatever. So which bit are you in?
Yeah, the Volvo Group is not a car manufacturer anymore. So our main business is around trucks. We are one of the leaders in trucks manufacturing. But we are also doing construction equipment. We are doing buses and some engine for boats. So that's our main activities.
Yeah, so that puts a box around what we're talking about because this is a very large industrial IoT story, 140 factories and millions of pieces of equipment. We'll get into all of that. So you said you joined 7 years ago. Here we are in 2025. So that makes it 2018. What was Volvo like when you joined from an IoT perspective, at least in 2008?
Yeah, so the first thing that I've seen is one team was working on what we call connected products. So basically the trucks that are on the road, and it was a really strong and mature team because we have more than 1 million trucks connected on the road. So we are gathering data from our product and it's working really well. On the other hand, I've seen the industrial IoT that there was no formal organization in place. So like in areas like smart factories, smart logistics, there was no formal organization. And I went all over the factories all over the world, and I've seen more than 60 IoT initiatives at this time.
60, 60.
60, yeah. It was quite big. We've seen really a big interest around IoT. However, there was no solution in production. So zero solution in production. So the challenge from the top management was to say, how do we escape POC hell? Everything was in this POC stage. And they asked me to investigate on the blockers. And I was able to see 3 blockers. So the first one was technical. So multiple platforms were in use. And when you want to put a new platform in production, you have to go through a big process with security review and all that stuff. And it takes a long time and big efforts. So that's why no one was able to fully complete this process. The second challenge was around the organization. OT people, so people from the shop floor, and IT people were working in silos. And for IoT solution, you need a strong collaboration to build something that is really strong. You need really cross-functional collaboration. That's a key. And the third blocker was the competence development. So there was no dedicated team for the IoT to support the initiative. And so it was super complicated for people to go from the POC to an industrial grade solution.
And I was thinking, certainly as somebody who, okay, I'm running an IoT company now, clearly, aside. But in my career, I've twice worked for companies, not with 100,000 employees, but 2 companies that both had 70,000 employees. In my case, it was HP and Cisco. But the 3 things that you described were exactly the same.
Yeah, that's pretty common.
Exactly the same, which is lots of people doing a lot of things apparently, but nobody had really implemented. Secondly, they were all working in silos. In fact, most of them were not even aware of the other people trying to work on one thing. And then thirdly, everybody that was, they're working independently and they weren't sharing any skills. They were learning the same lessons over and over again. I think what you're describing is a very common characteristic. Frankly, it happens in small companies, but when it happens in big companies, it's everyone's trying to do their best, but they're focused on each other and not achieving anything. So that was your starter, and you did your tour. And
so that was the 3 main blockers. And so what did I do in 2019? First thing, I've appointed an IoT platform for the group. So it was at that time, it was ThingWorks from PTC. So it meant that everyone was working on the same IoT platform. It helps a lot. The second thing around organization, build the Volvo IoT community. The community, everyone can be a member. There's no structure, only members. And we have built a community. So the first year, there was more than 200 members. So it worked really well. It was people, of course, from the shop floor, technical people, from the IT developers also. But we got people from the purchasing department, people from legal department, people from marketing. So it was a really diverse and really cross-functional. So it worked really well also. And the third thing about the competence development was to build an IoT team dedicated for that. And at Volvo is around 20 or 30 people. You can think it's big, but believe me, it's really small compared to the IoT needs of a group like Volvo. So really our strategy for the IoT team is to develop the major IoT solutions, but also to support the local team across the organization so they can develop their own. So we call that citizen development. And it's really key for us in our strategy to go at scale. Otherwise, we know that we will be too slow and we will be the bottleneck for the group.
If I'm understanding it correctly, that there are various different management approaches. We've seen fully decentralized, fully centralized. It sounds like yours is a blend, because in a fully centralized model, you take all the budget off everybody else and say, you have no budget. You have to get my permission. I have all the money and you have to get my permission. And that's often not very popular, but it is a good way of making sure that people don't waste money. Fully decentralized sounds like where you started from, but although you were spending money on the central components, like the common platform, no one can afford one platform. So I imagine you centrally funded PTC, but then most of your work is on being advisory, best practice sharing, collaboration, communication, the central center of excellence, if you like, for all the different people working on IoT. So as many initiatives can start off as possible, but at least they're all pointing in a similar direction.
Absolutely.
Yeah. Okay. So that's the basics. And maybe we can talk about what type of technologies you used, because there's an awful lot of equipment in those 140 factories. So is a large part of that equipment connected via a wired connection?
Yes, absolutely. So the majority of our IoT initiative is around existing data that are in factory. All the PLCs and industrial equipment are producing a lot of data. And it's not obvious to collect all this data in a unified way and to have quality data. So most of our work is around collecting existing data so it's wired, and it's also with various industrial protocols. We have really old PLC with years old or something like that. We have also brand new robots in our factories. All these animals are communicating in different ways. And so we are talking with all of these devices in a unified way and collecting the data. And, one of our big challenge is to have quality data. So quality data is to have an accurate value, but also in real time and also contextualized. So data that you can understand because of our project. And for that, we are using an industrial gateway to communicate in various protocols. And we have also some other projects where we are using LoRa. We're using LoRa a lot for smart metering and also for tracking, especially to track our trucks around the factory yard. But yeah, we have a lot of different projects. We are doing also some project for logistics when we are tracking our packaging. We're doing also some project around computer vision or quality control along the production lines. So yeah, a lot of different technologies.
Yeah. So we'll get into some case studies in a minute, but I'm just trying to paint a mental picture of the scope of what you're trying to do. You've got, first of all, you have 140 factories. They won't all be exactly the same, I'm sure, because you're in different businesses, marine, trucks, different areas of business. So the factories will be construction. So the factories will be different. Secondly, the factories have hundreds, if not thousands of pieces of equipment each. They can be anywhere from 30 plus years old to install a robot, autonomous robot that's been installed this week. So it's almost like a huge three-dimensional Rubik's Cube, where every single one of potentially you must have hundreds of different protocols connecting with devices where the connection to the device was only there so you could get limited data out of them for maintenance, I guess, maintenance purposes, but certainly not IoT. And then at the same time, you're using different networks.
Yeah.
So you're using wired through some sort of controller aggregator, but you're also using LoRa for wireless. And you didn't mention Wi-Fi. So I know the factories will have a lot of Wi-Fi. So why do you not, people might be interested, why do you not use Wi-Fi?
Yeah, Wi-Fi is quite challenging in factories because we are using it too much. So we have a lot of industrial equipment that are using the there's a big risk of interference and saturation of this frequency band. So we try to avoid to use Wi-Fi.
Okay. All right. Okay. All right. Let's get into some examples. So we got the size of the Rubik's Cube and where you started from. So maybe we can go through 2 or 3 examples. I know when we spoke previously, you were talking about AGVs, which most people are not very familiar with, but maybe automated guided vehicles. Maybe you can talk about that
Absolutely.
first. Yeah.
Yeah, that was my first IoT project. And I was in a factory in Lyon in France, talking with the maintenance, and I asked him, what is the most recurrent incident that have the worst impact on your business? And he was saying that more than once a week, he had a battery failure on the AGVs. So it's a fleet of 85 AGVs in this factory. And for different reasons, you could have an issue with the battery failure. And when it happened, it's 1.7 tons, one AGV. So you need 2 guys to push the AGVs out of the line and then to charge it or to replace the battery and then put it back. That's really a bad impact for the production because several parts are not produced and it costs a lot of money. So for me, it was like the low-hanging fruit because it was super easy to monitor the voltage of these batteries. And we built a solution to collect the data. And then we've seen that the nominage or the normal voltage of this AGV is 24 volts. And when it goes to 22, it stops. But then we analyze the data, and when we've seen that when it goes below 23 volts, it means there's an issue somewhere, but there's an issue. So we have built a system where we can send a notification to the maintenance team each time there's a page that is below 23. And then the maintenance team has something like 45 minutes before the failure happened.
Yes.
So it was a super easy predictive maintenance system.
Yes. Yeah.
And so now they can act before the failure happened, and it saved a lot of work.
And just for our listeners, again, this is a very visual case study for me. An AGV, 1.7 tons, takes 2 men to push. What goes on? Help me understand. What goes on top of an AGV? What would you use an AGV for?
This is for an engine plant. It transports the engine during the assembly of the engine, so in the production line.
Okay. Wow. 1.7 tons. And then
Yeah.
then you have to push it.
Yeah, it's a big engine truck.
Yeah. And then what about the trucks? You have I think a good case study. You talked about that one being your first one, the AGV, but this idea of just finding trucks. It's always amazing that companies like yours can lose something so big.
Yeah, it sounds crazy, but sometimes we cannot find our trucks. And why it happened? Because at the end of the assembly line, the truck is not fully finished. So usually you take the truck, you go to a factory yard to park it, and then an operator will take it, do some operation and park it again. So now you have to imagine that you are producing more than 100 trucks per day. You have a huge yard and most of the trucks are white. And now if there's a human error when writing down the position, then it takes 2 hours for 2 people to find the truck.
So and we've seen case studies like that all over the place, but rental car companies have exactly this problem, by the way. But these 2 people, the 2 hours it takes, is that literally a couple of guys walk around this huge?
No, they're taking a car and driving all around the factory yard.
Yeah. And they don't have registration plates on them, I assume.
No.
Are they like pressing something that makes the light?
No, because
the keys are on the truck. So how do they know it's the right truck when they find it?
There's a barcode with a big unique number on the windshield.
So they have to scan the barcode of every truck.
Oh no, they can read it.
So these guys are in the field looking for trucks which you lose.
Yeah.
So that was prior to IoT solutions. So how have you or how are you solving that problem now?
Yeah. So the first pilot was for one factory years, and that are working with the GPS and communicating with the LoRa technology. And at the end of the of the assembly line, your an operator is scanning the track, scanning the tracker, put the tracker on the track, and then we can follow the tracks in real time in the factory yard. And when it's done, and when the track is fully assembled, we take back the trackers and unlink it. Basically, there's a pairing operation and unpairing operation at the end. And it has worked really well using this solution. But moreover, construction equipment are also using this solution, and buses is also using this solution. So it's deployed all over the world for thousands and thousands of products. It was a big success.
Let's go from thousands of products to potentially millions. We've talked about your AGVs, and we talked about finding lost white trucks in the middle of very large fields or whatever.
Yeah.
But what about the assets themselves? There's a lot of things that move within these factories. I guess there's a lot of assets that move. You have to move parts from one place to another. So do you track those as well? Do you have a similar solution?
Yeah, tracking technologies grow, and we know that we have a lot of work to do in our internal logistics, so inside the factories, but also for external logistics for the goods coming from our suppliers, and also for the logistic between our sites. The logistic is something huge. Our processes are not perfect in logistics, so we can see that the stock numbers are not accurate for the different assets. And it costs a lot of money. It causes a lot of issues. So we are for the tracking technology. So we are building a tracking platform. And the first use case we are working on is around packaging, and more specifically around what we call spatial packaging. So just to give you some piece of the context, when you want to transport an engine from a plant to another plant, you cannot put it on a pallet because it does not fit. And the same thing for a truck's cabin, same thing for an axle, same thing for all these parts. So when you want to transport this part, you need a special packaging. So usually big metal racks that are really specific depending on the type of part that you want to transport. And if you don't have this special packaging at the right place at the right time, you can stop the production. So the risk is really big. And because this impact is so huge, sometimes we are doing express transport of this special packaging, and it's really tight. So what we want to do is to track all this packaging and to do automatic inventories at different points of interest. The big challenge here is that we have something like 200 or 300 points of interest, but we have 160K assets to track. So that's a big deployment. And that's just the beginning. Because at the end, we want to track 30 million packaging.
30 million.
Million. That's the goal.
Wow.
And this is just for the packaging. We know that we have a lot of other stuff to track.
Hold on, I have to stop you. I'm trying to do the maths. Let's say that 5% of 30 billion is 150K. You said 160K. So just on the packaging, you're at 5%, but there's going to be 30 million is what you want to do. But there's a lot of things you want to track ultimately beyond.
No, it's even worse than that. K is for the special packaging.
Special packaging.
30 million is for the standard packaging.
Oh.
But after that, we want also to track the parts, to track the tools, to track the forklift, to track, you name
Hundreds.
it, that we will track it.
If it exists, you'll track it. So massive IoT. All right. So this is a big long range, multi-year project and problem.
Yeah, absolutely.
How are you starting off solving that problem today?
Basically with a POC, or I should have say an MVP, so a minimum viable product.
Yeah.
And why I'm saying MVP instead of POC, because to start this kind of initiative, I'm not just checking that the technology is working. That's only one detail in the project. What I'm doing is I'm taking the purchasing department from the beginning. And also I'm talking directly with the business to build a first version that is valuable and scalable. So I want to be sure from the beginning that I can go at scale. So yeah, we have a different strategy for that. And one of the strategies is to build a big tracking platform that is vendor agnostic and technology agnostic.
Yes.
So the idea is we can plug any kind of trackers from any vendors, and we can solve a lot of use cases.
And we did talk a little bit about this previously. I think in this use case, we talked about Wired, we talked about LoRa, but I think I'm right in saying, Julien, that in this case, there is you use BLE, so Bluetooth
Yes,
tags to cellular gateway and then backhaul the data from the cellular gateway.
absolutely. Yeah.
So you're really using a little bit of everything, and you've got so much more in front of you to do. That's probably a good opportunity to pivot from what you're working on. I'm sure there's a lot of other projects, but what you're working on to
Yeah.
the future, because maybe we could talk a little bit about what you're doing, because, and let's start off with LoRa, because I believe that on the metering side, smart metering in particular is something that's energy management, smart metering is something that's of huge interest to Volvo.
Yeah. And we're just at the beginning also in this domain of devices to do metering. So for water, electricity, for gas. But we have so much more to do. The energy management system is, for the moment, we don't have any centralized solution. So it's all decentralized at Volvo. And we would like all the plants to have the same solution so really to mutualize the efforts and to be better in this domain. So we are really expert now. This network is deployed in the main factories at Volvo, and it's working really well to do a good job, promote the solution and to deploy it at scale. That's how we are.
Why don't we finish on a big subject which a lot of people are talking about? And I would say a lot of people are frankly a little confused about, but everyone's talking about it, which is artificial intelligence.
Yes.
And AI at the edge. Now, that has got to be a big topic. You must be asked about that by management. And can we not use AI? Can we use AI to improve this?
Yeah, I'm convinced that AI inference at the edge will definitely revolutionize several domains and it will help a lot. However, often the management is saying, oh, we can solve everything with AI. And they don't really understand how it works. So I'm used to say, okay, you can use AI, but only if you have good IoT solutions. And why I'm saying that? Because the goal of IoT is to get quality data. And that's the foundation to build an AI model. So if you don't have quality data, you will not get anything from AI. Crap in, crap out, as they say. IoT initiative, IoT project. Then you can build some good AI model and have great values with that. But it's you have to do that by stage. And for example, for the logistics, we don't have good numbers for stock. And they have tried to put some AI on top of that. We didn't get any results. As expected from me, the result was not good. And I know if we can put a good tracking technologies that can have accurate data, then we will have a good result with AI. So that's the lesson now, good usage of AI.
And I want to come back to that. And when we talk about the edge, which let's assume the assembly line, I assume it's not also the vision is not just AI, it's the human interpreting the recommendation of AI so they can make quicker decisions locally rather than based on what's actually happening from the data being collected from the assembly line?
Yeah, definitely. That's one thing also that we are deploying all around the world. It's super important to be at the edge. Why? Because when you are doing quality control, if you see that something is wrong, your AI model is saying the quality is not good enough, then you will stop the line. You will stop the production line. And you definitely need an operator to understand why the algorithm is saying it's wrong, why the line is stopped, to take the right decision. So it's not only good technology, but it's also skilled people. And that's why AI at the edge could make a big difference because you can be robust as a network, not network dependent, but also with a low latency and with a direct interaction with the people that are working on the production line.
So I think that what you've said there, as we finish it, I think what you've said there is that conventional wisdom, or at least there's so many podcasts around about AI and you read about AI, and you said two things which I think everybody would agree with. But I think you've said one thing which most people haven't, the penny hasn't yet dropped. So let me attempt to summarize that. I think everybody talks about the fact that AI is not going to automate everything. It's going to be AI and a human. There's a lot of debates about will the humans' jobs go away? And what you're actually saying is, no, you need to take real-time decision at the data, especially at the edge, especially if you're going to stop the line. You can't just rely on AI. You need AI and the human who has a lot of more knowledge, a lot more capability to say, can I trust the data? Should I stop the line or have I seen this before? Am I okay to let it go through? Most people would say, yeah, it's always AI and the human, AI and the human. And the second thing that you've said is that you're crap in, crap out, which is true. And it's only as good as the data you put into it. And of course, AI is well known for hallucinating, and it hallucinates really well. It's so convincing. Even in the research paper field, it will invent research papers from professors that don't exist. And so it can certainly invent a situation on an assembly line. But the thing that, and most people say, yes, it's only as good as the data. But I think the point that you've made, Julien, as clear, and we've talked a lot about AI on this podcast, but as clear, if not clearer than anybody else on the podcast, is that IoT is essential for AI. And I don't think that penny has dropped because what you're saying is you've got to collect as much data from as many things as accurately as possible with the highest level trust that it's the real data to feed the AI model. So the more data from real life things and events that you collect and feed into your AI system, the more you can trust the output of the AI system. And IoT is, my words, not yours, but IoT is essential. IoT deployment and connectivity of as many things as possible is essential to get the maximum benefit out of AI in the future. Would that be a correct statement?
Yeah, great job. Great summary.
Well, that's summarizing what you said. I think that's really important because we see a lot of niche. We have about 800 customers, mostly industrial customers, but at SI, but we see a lot of niche use cases where people say, oh, I'm going to do this project. I'm going to collect data from that group of things. What you've talked about is wired. You've talked about LoRa. You've talked about sensors, wireless, and now massive, the 1.6 million, the 30 million, and the many 100 million. The idea of connecting everything, which we've talked about for a long time, everything that has power will be connected. We've talked about that for a long time. And what you're saying is, and the reason why you need to connect everything by whatever technology or protocol is because to get the maximum benefit and the productivity and the efficiency out of AI, you need to feed it with all of this data, because you can't scrape that data from databases on the internet. It's not academic content. It's not or books. You can scrape the internet, get every book in the world. And so I do agree with you. I think that one of the reasons why people will start to accelerate connectivity of everything is not because they want everything to be connected, but because they're under pressure to actually get a better AI model. And I think that's something which people are only just beginning to start talking about. Volvo is a great example, in my view, of and what you're doing, of a company that gets that and is embarking upon a very ambitious project to literally connect everything in Volvo, which is a multi-year journey, which is your job.
Yes, it is. Yes, it is.
That's right. And you're still smiling. Okay. Listen, we are just around about the exact time that we use for these podcasts. So I'm going to leave it there. So I wanted to thank you for describing it so well and agreeing to come on the IoT Leaders podcast. For those of you who perhaps want to reach out to Julien on LinkedIn or whatever it is, Julien Bertolini at Volvo. He's based in France. And a very interesting story around a very large company who are pretty advanced in this space, but also at the same time, very honest in opening up, in describing what you have done and what you haven't yet done, as opposed to saying that you've solved everything, which is very refreshing. So I will leave it there. Julien, thank you very much for
Thanks a lot.
being a guest on our podcast. It's been a pleasure to talk to you, and good luck with connecting hundreds of millions of things going forward.
Thanks a lot.
Bye-bye, and good to talk to you. Thanks, Julien.